Okay guys, now before we go to axis of symmetry, when you draw the function, we mark the shape of the graph, whether it's in the right quadrant, we mark the asymptotes, all right? Then we also mark the intercept. I need to know where it cuts here. You see, we didn't show here. And also the x-intercept. This is the y-intercept and this is the x-intercept. How do we calculate intercept? For y-intercept, for y-intercept, we make x to be equal to 0. So we're going to say y, which is f of x, equals, on f of x is the same as y, g of x is the same as y, 2 over, on x we put 0 minus 4, on x we put 0, then there's a minus 3 there. So this is just something you just simply put on your scientific calculator, 2 over 0 minus 4 minus 3. So this is minus 7 over 2, of which in commas is minus 3 comma 5. You're done. This is your y-intercept. When x is 0, y is minus 7 over 2. This is your intercept. So for my x-intercept, I must make y to be 0. So here on f of x, remember I said f of x represent y, I must make it 0 equals to 2 over x minus 2 minus 4, minus 4 minus 3. So I'm going to take 3 to the other side. It's going to be 3 and 2 x minus 4. I can make this over 1 so that I can cross multiply. 1 times 2 is 2, and then this times this is going to be 3 x minus 4. Then it's simple to multiply out that bracket. It's 3x minus 12 and 2, this goes that side, 2 plus 12 equals to 3x. So this is going to be 14 over 3 equals to x, right? So x is 14 over 3 is going to be 4,7 equals to x. So in coordinates, when x is 14 over 3, y is 0. So that is our x-intercept. So where do we put it? Our y-intercept is minus 7 over 2. So we show them here that this is minus 7 over 2. So you must show it. And this is it what? 14 over 3 here. So this is 14 over 3. Then you're done. Then now, what is the domain of the function? The domain is all the x values that are part of the function. All the x values that are part of the function. So here you can see that the graph involves all x values up until negative infinity, and here all x values up until positive infinity, except this x at equal to 4. Because when x equals to 4, the graph is not defined. The graph must not touch this x value here. So what is the domain of the function? Domain is all, x is the element of all real numbers, but x must not be equal to 4. That's how you put the domain. Then here you can see the graph. This is the domain. The graph here involves all the y values going down and all the y values going up, except this one here. So the range is x element, not x, y element of every real number, but y must not be equals to -3. So that is your domain and your range. Now, there are two axes of symmetry. Symmetries, they are like mirrors, right? Symmetries are like mirrors. There is the axis symmetry. This graph has got two axis symmetry. There's axis symmetry with a positive gradient. Remember, when a line has a positive gradient, a straight line, it's going to increase like this. So this is a line with a positive gradient. This is a line with a negative gradient, right? So the one with a positive gradient, the axis of symmetry, we get it by this equation. Y equals to x plus c. And the one with a negative gradient, we get it with y equals to minus x plus c, right? So what is an axis of symmetry? Let me illustrate it on our function here. This is my axis of symmetry. It must pass through the intersection of the asymptote. This is my axis of symmetry, and you can see the way the shape is the one that has a positive gradient. And then this one is my axis of symmetry with a negative gradient. This one, you can see this is like a mirror. It's like a mirror of these two guys here. This guy must see himself in here, reflected by this line, and this part here sees itself here, reflected by this line. So this is a positive gradient, this is a negative gradient. Now this equation, how do you find it? And this equation, how do you find it? The one with a positive gradient, we use this. Now the intersection here, the coordinate of the intersection, the x coordinate of this intersection is 4, the y coordinate is -3. That's what we put on x and y to find c. So on x, I'm going to put 4. On y, I'm going to put -3 plus c. So this goes the other side, is -3 plus 4. -3 minus 4 equals to c, because 4 went the other side. So -7 equals to c. So I go back to the equation, cancel c, and put -7. So this is going to be x minus 7. X minus 7. This is the equation of this one here. And then this one here, we're going to put that. On y, we put -3. On x, we put 4, but there's a negative, so it's going to be -4 plus c. This -4 goes that side, -3 plus 4 equals to c. And then this is +1 equals to c. So we go back there, we put +1. So this is the equation with a negative gradient. This is an equation with a positive gradient. So lastly, I'm going to be doing reflections, and then I think we'll be done with this topic.